Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue this section B kind of topical MCQs on topic 3, which is on structure and bonding. So with these section B kind of MCQs, we are still dealing with the 4 common multiple choice options, but we're comparing statement, we're comparing 3 statement or 3 options, where if all statements are relevant to what they're asking, that's option A. 1 and 2 will be option B, 2 and 3 is option C, and if only 1 is relevant to whatever they're asking, they will give you option D. Therefore, by default logic, we always go for option 2 first and see if it's relevant to whatever they're asking, because if number 2 is wrong, then you're only left with 1 option and you can move on. But you need to be very careful. Either you work it out or you know it by facts, or you can just, by logic rule out option 2, then it's very easily D, okay? But I mean, there are various tricks around these kind of questions, but it all comes down to reading the question and being very careful with phrasing, because sometimes it feels more like a test of language rather than a test of chemistry, okay? Anyway, let's get started. So in this question, which of the following molecules and ions have a regular trigonal planar shape? So trigonal planar shape means you have 3 bond pair, where we only count the 3 sigma, and you have 0 lone pair, and therefore the 3 bond pair repel equally. So in a theory paper, you never write BP and LP, okay? These are just my abbreviation, and you'll see me use a lot of these when I talk about VSEPR, when I explain valence shell electron pair repulsion theory. You gotta talk about the repulsion. In the case where there's no lone pair, they will repel equally. That's why it's called electron pair repulsion theory. And a lot of students, when they talk about shell molecule, they don't even understand that it's based on valence shell, outermost shell, electron pair repulsion theory. Okay, so that thing will give you a trigonal planar geometry of 120 degree. If I look at option 2, this is a carbon with 3 hydrogen. I've purposely drawn as such because I know it's trigonal planar. Carbon has 4 outer shell electrons, being in group 14. So it's used 1, 2, and 3 for bonding. It should have 1 more electrons on the carbon. But you have a plus charge, means it has lost 1 electron. Guess what? It has 4 outer shell electrons, it's lost 1. Now it's got 3 outer shell electrons, which it used all 3 for bonding. So there are no lone pair left on the carbon. But there's 3 sigma bond around the carbon. So guess what? That is your trigonal planar geometry. Alright, because the 3 bond pair repel equally. If I go for option 1, aluminium doesn't need to have a charge because aluminium is in group 13. It's got 3 outer shell electrons. It uses 1, 2, and 3 for bonding to the chlorine. There are 3 sigma bond, so there's 3 bond pair. And there's no more electrons left on the aluminium because it uses all 3 of its outer shell electrons for bonding. So the 3 bond pair again repel equally to give you trigonal planar geometry. If I go for option 3, phosphorus is in group 15. So it's not the same as carbon plus or aluminium neutral, because now you have group 15, you have 5 outer shell electrons. He uses 1, 2, and 3 for bonding, because 3 sigma bond, there's 3 bond pair. But you're left with 2 electrons on the phosphorus. They are not used for bonding. So you got 1 lone pair of electrons. And because we talk about electron pair repulsion theory, your bond pair, lone pair repel more than bond pair, bond pair. Previously, your 3 bond pair repel equally, but here they don't repel equally. In fact, if you have 2 lone pairs, such as in water, they will repel even more between the lone pairs compared to this, compared to that. But there's only 1 lone pair, so there's no point talking about lone pair repulsion when you don't even have it in your molecule. And that's the danger in theory paper, where students just write whatever they know without even relating to the question itself, yeah? So that is going to be 107 degree, or some students or some teachers or some books like to say 107.5 degree, and that is not trigonal planar. That is instead trigonal pyramidal, like an umbrella, okay? So only 1 and 2 are correct. That's option B. So this next question, they're asking the same kind of deal, planar. but I guess planar can mean different thing, but planar essentially is just flat. Alright, let's work out geometry. NH3, just like the previous question, pH3. Nitrogen is in group 15. NH3 is also your case study for your shape of molecule. So you gotta really know it. Okay, I'm drawing the three-dimensional structure. This is flat in the paper. This is bolded wedge line because this is pointing at you right in the eye. It's coming out from the screen, coming out from the paper, pointing at you in the eye. This is flat. This is going away from you, pointing away from you into the screen, into the paper. Alright, this is 3 bond pair and 1 lone pair because nitrogen is in group 15. It's got 2 electrons that are not used for bonding. It only uses 3 of the 5 outer shell electrons to form 3 sigma. Okay, so your bond pair, lone pair, repel more than bond pair, you get trigonal pyramidal and 107 degree or 107.5 degree, and we know that is not planar. Number 2 is not planar. You are really left with one option, which is option 1. In the previous question, we covered aluminium trichloride, AlCO3. Boron is above aluminium in group 13. It's also got 3 outer shell electrons, which it use all 3 for bonding. So you only have 0 lone pair and 3 bond pair because it uses all 3 of your outer shell electrons for forming covalent bond. So down to 3 bond pair just repel equally, giving you a trigonal planar 120 degree geometry. pH3, covered in the previous question. Phosphorus is just below nitrogen in group 15. So replace this nitrogen with phosphorus, you're still going to have 1 lone pair and 3 bond pair. Okay, so pH3 is also trigonal pyramidal 107 degree. So I can, phosphorus is the same thing. Okay, because group 15, you have nitrogen, phosphorus, blah, blah, blah. In this next question, so this is from November 5, 2005. So back then they still used the Roman numeral, which you will have used in O-level. I'm not entirely sure about GCSE or IGCSE, but in A-level, depending on your specification and your periodic table, at least in the Cambridge International, they've changed to group 13 to represent the aluminium, the boron group, gallium, where you have 3 outer shell electrons. So boron is an element in that group. It forms a compound called boron nitride. It has a graphite structure, so it's layered. When you think about carbon, that has got 4 and 4. I'm talking about the valence electrons. Alright, when you have boron and nitrogen, boron is group 13, nitrogen is group 15, so it's got 5 outer shell electrons. That's group 14 and group 14. Alright, when you total them up, they have 8. Can you see now why boron nitride can have a graphite structure? Because they are isoelectronic to a carbon-carbon. So in the graphite structure, you have a layer structure and you can conduct electricity because you got 3 electrons on each carbon throughout that giant molecular network. So which of the following conclusions can be drawn from this information? Alright, so it says the boron and nitrogen atoms arrange alternately, hexagonal pattern. So you know graphite has that kind of arrangement. I can't even draw the hexagonal very well, but you know, they have layer, structure. I don't know if I've drawn hexagonal or not, okay? Where you have van der Waals forces between the layers, which you can slide over each other easily. But each carbon is bonded to only 3 other carbons, so you got 3 electrons on each carbon. These are hexagonal pattern. They get repeated throughout in a giant molecular network, and that is what the boron and nitrogen will replicate because it adopts the graphite structure. Alright, the empirical formula of boron nitride will be Bn, because as I've shown here, you gotta have one of these and one of these to match up the isoelectronic nature of a carbon-carbon bond in graphite. But when you have just graphite, which is just carbon atoms, so what you have will be carbon and carbon will be C2, but then there's not the simplest number. The simplest number of the atoms in graphite or in diamond is just carbon, because there's the empirical formula, just carbon. But Bn, the ratio is 1:1 for you to match the isoelectronic feature of a carbon-carbon bond in this kind of graphite structure. So indeed, the empirical formula for boron nitride is just Bn. In the third bit, boron nitride has a layer structure with van der Waals forces between the layers. If it does indeed adopt the layered graphite structure, we know the graphite has that weak van der Waals forces, which I have drawn, and that's the reason why graphite can act as a lubricant, because they can slide over the layer easily because of just overcoming the van der Waals forces. So 3 is also correct. Therefore, all 3 options are accepted. Question 9. So we are looking at these solids, and we are looking at which one contain more than one type of chemical bond. If we have graphite, remember just now in the previous question, we talked about van der Waals between the layers. Alright, that is intermolecular forces, but that is just between the layers. But you also have covalent bonds. And that is what you break the carbon-carbon covalent bond when you want to melt graphite, because it has a giant molecular structure. And that is the very reason why graphite has a very high melting point, giant molecular structure. You have to break many strong carbon-carbon covalent bonds within that network to melt it. Alright? So indeed you have more than one type of chemical bond. When I check number 1, brass is an alloy. An alloy is a mixture, and you have copper and zinc, so it's a mixture of metals. So you just have metallic bonding. You have metallic bond of copper, you have metallic bond of zinc, but they are still elements being mixed together, so each of them still retain their individual metallic bonding. Alright, so there's no covalent or ionic or whatever, it's just metallic bonding. That is just one type of bonding. In ice, this is a very special one. This is called hydrogen bonded solid network. It's specifically stated actually as part of your stats of matter in topic 4, where it overlaps with topic 3, structure and bonding a lot. Alright, so not only you have OH and OH, but you also have the very strong hydrogen bond, because imagine when you are in solid state, your molecules are so much closer together that they only vibrate about fixed position, things you have covered in lower secondary sciences. You know how the molecules or the atoms or the particles, how they are arranged in the solid state, so close together. Don't forget your dipole. So these things are H bond. They are very strong because they are very close together. This thing in pink are covalent bond. When you are in liquid state, liquid water, they are not as regularly arranged as in the solid ice, where they have this hydrogen bonded solid network, where the bond angle is about 109 degree, because they are so close to each other that they kind of matches, that they kind of mimics a real covalent bond. Imagine without the lone pair, where the lone pair is being tied up and used to form strong hydrogen bond due to how close they pack. It is as if the oxygen has 4 bond pair and 0 lone pair. Alright, because they're so close together that it matches like 4 bond pair and 0 lone pair, 4 bond pair repelling equally, tetrahedral 109 degree. But this is only in ice, okay, only in ice because of that hydrogen bonded solid network. You have covalent bond, you have hydrogen bond, you have 2 types of, you have more than one type of chemical bond, you have 2 types of chemical bond altogether. So there's option not B, but option C. this is the last question of this 5-question series on chemical structure and bonding. So we use sodium hydrogen sulfide to remove hair from animal hides. So your sodium in a compound is going to be ionic, like that. So your negative charge is on the sulfur. So which statement about SH minus ion are correct? Alright. What you know about OH2 is that it's got 2 bond pair and 2 lone pair. When you have H2S, alright, there's hydrogen sulfide. Sulfur is just below oxygen. It behaves the same way, okay? Like band 104 degree or 104.5 degree. When you have SH minus, okay, why does it have a minus? Well, think about this bond. When this become H plus, so 2 of the electrons must have gone to sulfur. So your sulfur would actually have another lone pair, and that is actually what makes it minus, because the original electrons is from the sulfur, but it has gained 1 extra electrons as a result of this bond being broken, and you can get SH minus. Okay, so extra foreign electrons give you the overall negative charge because you gain 1 extra electrons than what you normally have. The blue one, 1, 2, 3, 4, 5. The 6th one is used to form covalent bond. This is the extra electron that it has gained, minus 1 charge because you gain 1 extra electron. Altogether, you have 1 lone pair, 2 lone pair, 3 lone pair. So 3 lone pair is correct. And that's around the sulfur atom. It contains 18 electrons. Well, if you look at SH minus like this, work out the number of proton. Sulfur is element number 16. Hydrogen is element number 1. You have 1 of each. Work out the proton first, always, as you will know from atomic structure topic. Once you work out the number of protons correctly, based on how many you have, the number of electrons depend on whether you are atom, molecules, or ions. You are an ion. You are a negative ion. You have negative charge because you have gained 1 extra electron. If you have 2 minus, you have gained 2 extra electrons. You have a minus 1, you have gained 1 extra electron, so that's 18. They don't ask for neutron, so I don't bother about neutron. Alright, so it does contain 18 electrons. Sulfur has an oxidation state of +2. So you do more on oxidation state when you reach topic 6 in my classification. So that's to do with redox changes. But some schools or some levels, before you reach N levels, will have done oxidation state before. If you think about oxidation state, this is a compound. Oxidation state of a compound is 0. Sodium in a compound has oxidation state of +1. Sulfur is what you want to find. Hydrogen, you have 1 of it. And then each hydrogen in a compound is hydrogen +1. So 0 equal to +1 plus sulfur +1. Sulfur is -2. Sulfur is not +2. So 3 is wrong. Only 1 and 2 are correct. That's option B. So that's the end of this 5-question tutorial series on structure and bonding. Thank you for watching. Click the button on the bottom right if you haven't subscribed to the channel. Check out the other topical playlists as well, including other topical multiple choice question playlists, because not just when I go through the multiple choice questions, I don't just go through the MCQ itself, because each option actually provide a very good discussion for a theory level question. So do catch those out and start building up your chemistry understanding in your theory section as well, by going through this MCQ with me. Alright, and thanks for sharing this channel with your friends, your class group chat, your juniors, your seniors, anyone else really you think this channel might be useful for. Alright, I'll see you in the next video.